Hi, how are you?
I'm great.
What about you? Great, thank you. All right, so before we start, I'm gonna show you something the magic of our nature. As you have seen before, this world is full of nature, full of wondrous things. But do you realize that around your surroundings, there are magic itself? I'm gonna show you something. Please hope works. Check, test, test, test. Yeah, consider that works, okay? Yeah, all right. It should be working, but all right. So, incredible, yeah, incredible. It's supposed to be working. I worked it for several times before, but it works now. Why don't you work? Hey, okay. Was it incredible?
Yes.
So, let's delve into the realm of scientific inquiry and discovery.
Incredible. We anticipate absorbing knowledge from you, Mr. Einstein.
Appreciated budding intellect. Science is an enthralling field. Remember, curiosity is the catalyst to deciphering the enigmas of the cosmos. Do you understand that? Oh, good, good.
Yes. We've been engaged in our experiments for some time, eager to unveil our findings.
That's commendable. Science symposiums provide a platform for your innovative prowess and scientific acumen. Every eminent scientist began with a rudimentary query and a thirst for answers. Are you thirsty for your answers?
Yes.
Good answer.
We've assimilated a lot about the scientific method and experimental conduct. It's been a thrilling expedition.
Splendid. The scientific method is the bedrock of all scientific breakthroughs. It facilitates hypothesis testing, evidence collection, and conclusion formulation. Even an unexpected experiment outcome offers valuable insights.
We're keen to observe other students' projects. These symposiums are a great way to learn reciprocally.
Yes, indeed. Collaboration and idea exchange are crucial. Take a look, we have a lot of booths here. They are exchanging their ideas, their knowledge, so that this very symposium could emerge. Community, scientific community is important. Remember, innovation often stems from expanding upon others' discoveries. So, engage with your peer scientists today.
We're thankful for this chance to display our projects and learn from you, Mr. Einstein.
Well, the honor is mine. Science is a perpetual quest. Don't forget that. You keep learning, learning, learning day by day. Because if you embrace the unknown, probe, and let your curiosity steer you, I eagerly await the unveiling of your remarkable projects.
Thank you, Mr. Einstein. Let's make this science symposium unforgettable.
Absolutely. Let the symposium commence, and may the essence of discovery pervade. But beforehand, why don't we warm our body up by burning our calories through this very exciting movement? Are you ready to follow my move?
Yes.
All right. Fellas, students from lower grade, from higher grades, elementary students, lower grades too. Come on, enjoy and join our movement. Let's burn our calories and follow your science comrade over here in front of you and follow our move. Are you ready? Are you ready? Okay, if you will, do you want to see your parents move too? Uh-oh. Who wants to see their parents move? Would you mind calling your parents for us? Mommy, Daddy, come on, join us. All right. Would you mind joining our movement, parents? Yay! Are you ready, fellas?
Yeah!
Okay. So, ready in 3, 2, 1.
Science explorers exploring science from Earth to the sky.
That's our movement. Don't forget to open your leg when you jump. Okay, one more time. Are you ready?
Yeah.
Don't forget to open your legs, all right? Science explorers
Exploring science from Earth to the sky.
All right, that's a bit embarrassing, but okay, let's enjoy. Please have a seat. And that was an energetic movement, wasn't it?
Yes. What an energetic movement, Prof. That makes us really ready to explore various fields of science. It's going to be quite an intellectual adventure.
That's right. And to start us off, we have a group that's about to blend the past and the future in a fascinating way.
Wait, blend the past and the future. Interesting. Most certainly, student. How is it?
That's a tough, provoking question, Professor. We're all eager to find out. So without further ado, let's welcome our first group to the stage.
Let's unravel the mysteries of the ornithopter together.
Ornithopter by grade 1. Please welcome our first group.
Group 1!
Welcome, everyone! Are you ready to explore the fascinating journey about the ornithopter? Yes? Well, let's jump right in. Using our science fair presentation that is titled The Transformation of the Ornithopter. Now we are going to discover how an ornithopter, which is an aircraft that flies by flapping its wings, transforms elastic potential energy into kinetic energy. First, what is energy?
Energy is the ability to do work.
It cannot be created nor destroyed.
Do you know is the inventor of the ornithopter? It was Leonardo da Vinci. If you really want to learn his biography, you are very welcome to visit our booth.
And if you're wondering how to make an ornithopter, here's how to make it.
Do you know what are the materials and tools?
The materials we need are
First, sticks from balsa wood.
Second, a plastic bead.
third, a thick and strong rubber band.
Fourth, a plastic tube.
Fifth, a wire or a paperclip metal.
And here are the tools.
First, a hot glue gun.
Second, cutters.
Third, pliers.
And finally, the procedures.
First, stick on the wood to make the shape of the body.
Second, glue a tube on the top and bottom of the wood.
Third, make the wing spars or bones.
Fourth, insert the wings, spars or bone into two tubes at the top of the body.
Fifth, make the tail spars or bones and a hook at the back of the body. Six, make a crank or a motor hook, then insert it into the bottom tube.
7. Tape or glue a thin piece of plastic on the a wings and tail.
8. Insert a thick rubber band on the crank and the back hook.
9. Out of popsicle sticks, make one hole at the top and bottom. You must have 2 pieces.
10. Insert the stick holes into the crank and wing spars, then
Have fun! This is how an ornithopter converts elastic potential energy into kinetic energy.
an ornithopter stores energy, which is elastic potential energy, into the twists of an elastic band.
Untwisting the bands converts to kinetic energy of flapping wings.
Flapping wings push down and back on the air, which applies an up and forward thrust force on the bird.
Thrust force keeps the bird in the air longer than gliding alone. More potential energy give more kinetic energy and longer flight time.
Now, this is the exciting part, friends. Who knows? What will we do?
Are we gonna make it fly?
Exactly! We're gonna make it fly across the room. Are you ready, everyone? You have to twist the crank 30 times counterclockwise. Let's have a countdown from 5 seconds. Ready, friends? Start from now. Still flying. Now here are the results and conclusion.
Conclusion. This project demonstrates how different types of energy can convert to each other.
And the results are, it can flap and make flapping sounds like a bird. It looks like a robot. And one extra, it can fly just by a rubber band.
Before we end our presentation, I have one question for you. What is the definition of an ornithopter? Anyone?
Yes, over there. Keith.
It flaps like a bird.
Sorry?
It flaps like a bird.
It flies like a bird.
Wow.
Oh, it flaps like a
Good
bird.
job, but that's not fully correct. Good try though.
Ooh, good try, Keith.
Very close.
Rafa. Oh, lower. Who wants to try to answer that question? What was the question again? Would you repeat that for your lower grades, friend?
What is the definition of an ornithopter?
What is the definition of an ornithopter? Yes? Okay, would you mind telling your friend the definition of ornithopter itself?
The definition of an ornithopter is an aircraft that flies by flapping its wings, just like a bird. We appreciate all of you for following throughout and being present during our presentation. We wish you for a very happy presentation for all of the other grades, and we hope all the parents can say happy and joyful for today.
Transformation of the ornicopter. Was it ornicopter? What was it?
Ornithopter.
Ornithopter, yes. It's fascinating to see how an ancient concept can evolve and still hold relevance in today's technological advancements.
Absolutely, Prof. It's a testament to the timeless nature of scientific exploration. Speaking of which, our next presentation will take us on another journey of discovery.
Another journey of discovery. Kinetic energy. The energy of motion is everywhere around us, from the smallest microorganisms to the largest celestial bodies over there. I'm excited to see how this group has explored harnessing this energy for power generation.
As are we all, Professor. So without any further delay, let's welcome our next group to the stage. Let's discover the power of movement together.
Please welcome
Group 2.
second group.
Check.
Good morning, teachers, parents, and science explorers. In this Science Fair Day, we will present about generated power by kinetic energy. Energy is broadly classified as kinetic and potential energy. Kinetic energy is the energy an object has because of its motion, while potential energy is stored energy in an object due to its position, properties, and forces acting on it. Today, our group will present about how power can be generated by kinetic energy, mechanical motion in this regard.
There are some material we need to make our model in here, such as paper, pencil, glue gun, cardboard, scissor, ruler, and compass stationery. Also, we need working tools, soldering iron, cable, LED lamp, and O-ring belt.
With all the mentioned materials, we made the mechanism first by cutting cardboard and shaping it into circles for wheels. Second, prepare the platform using plywood and 3 wooden blocks for the wheel and dynamo to stand. Place O-ring rubber to connect the dynamo and the wheel together. Lastly, by using cables, connect the dynamo and LED lamp inside the simulation house.
Now let's see how it works.
If you cannot see the demonstration clearly, you may look at the video. You can see now that the lamp inside the house is on. It happened because of mechanical movement. With constant movement, we could create stable electricity.
The energy through our model here is called kinetic energy because the source is from constant movement or motions. We need dynamos to convert mechanical energy into electricity energy. The bigger the dynamo, the more electricity or energy could be generated.
As the conclusion, kinetic energy can be generated by a constant force or movement. With the same concept, cycling motion could be obtained from wind and water motion, such as waterfall and river stream. That is why people invented the wind turbine and the... This is how it works. Thank you. The energy that is generated from nature, like wind and water, is called renewable energy.
Now, I have one question for you. What do we need to convert mechanical energy into electrical energy?
Yes. Jenny. Wait a minute. What is it, Jenny?
Water.
Water? Is that correct?
I'm sorry, but that's incorrect.
Oh, thanks. Thank you for trying, Jenny. Venetian. Oh, cannot. Sorry. Moses.
What was the question again? What was the question?
The question was, what do we need to convert mechanical energy into electrical energy?
Three, two, one. Okay, sorry. Next. Austin.
By kinetic energy.
Kinetic energy?
I'm sorry, but that's still wrong.
Oh. Can you give us choices?
The choices are cables or dynamo.
Oh, cable.
Or dynamo.
Angela.
Maybe cable.
Cable.
No, that's still wrong. I'm so sorry.
All right, would you explain it for your friends here? How does it work?
We need a dynamo to convert mechanical energy into electrical energy.
So, the energy is converted into movement by using dynamo. All right, thank you.
Thank you all for paying close attention to us while we present our presentation. We all appreciate it. Thank you.
Well, I feel so refreshed and I reminded of my theory. It was energy equals to, what is the M? What was the M again? Mass times. I remember the formula. E equals to mc square. Oh, all right. So, energy E equals to mc square. That was my theory. And then, are you aware that energy can originate from a variety of sources and undergo transformation?
I know that energy can be transformed into a different type, and my friends from group 3 will show you the proof that that energy can be transformed with their experiment.
Oh, let's see. Let's see, group 3 now. Welcome to the stage, group 3.
Hello, everyone. We're going to show an amazing experiment. I'm Aaron.
And I'm Giselle.
I'm Ilona.
And I'm Jose.
And I'm Marquez. Now, get ready to join our adventure.
We will explore the principles of force, motion, and how air can make things move from this balloon-powered car.
The materials are 5 popsicle sticks, 1 balloon, 1 rubber band,
and one four bottle caps, and one popsicle sticks.
The procedures are: first, glue the popsicle sticks on the model car. Also cut a popsicle stick in half. The second, then and then glue the half popsicle stick on the car. Third is cut the big straw and put a chopstick in it. Fourth is cut one hole in each bottle cap and glue it on a chopstick. The fifth one is glue the straws on the bottom of the car. Sixth is put a rubber band on the balloon. And also wait, put a rubber band. Yeah, and put a straw in it. The seventh one is put a new rubber band on the half popsicle stick and put it on a balloon.
Right now, we are going to demonstrate our balloon-powered car. If you can't see clearly, you can look at the video behind us. You have to blow the balloon about this size. Make sure you shouldn't bite the straw or else it won't go. And you shouldn't let the straw go down or else it won't also move. You let it go and it will move forward.
It's going down. Oops, I guess the car won't move. Can we try one more time?
Both straight and at least it works. The results are that when we blew up the balloon, the car went forward because the air thrust it out. When we blew up the balloon and let it go, the air inside the balloon rushed out backwards. This rushing air created a force of motion pushing against the air outside the balloon. The direction in which determine the direction of the car moved. The air pushed backwards, the car moved forward. When we use a larger balloon, it made the car move faster.
The conclusion is that air is strong. The conclusion is that air is strong enough to push the balloon-powered car forward. We need a lot of air in order to push the balloon-powered car.
All right, question time. What are the materials of the balloon-powered car? A, balloon. B, plastic.
Okay, I saw Jaska. Raise his hands first.
Balloon. That is correct.
Yay, that was correct, Jaska. Congratulations.
I appreciate for you all paying attention and listening to our presentation. Thank you and God bless you, and also please visit our booth.
Bravo! That was an excellent demonstration of an equal and opposite reaction. My comrade in arms, Newton, do you know Newton, Isaac Newton? That was my friend in arms. Third law of motion with a balloon-powered car.
Wow, that's brilliant. That's impressive.
Baik, setelah melihat beberapa penampilan dari murid-murid dan anak-anak ibu bapak sekalian yang sangat menakjubkan, mari kita beri tepuk tangan sekali lagi untuk penampilan dari murid-murid kita dan anak-anak kita. Penampilan yang meriah, yang mewah dari anak-anak. Adakah dari Bapak Ibu yang ingin memberikan respon atau kesan untuk penampilan ketiga kelompok yang sudah tampil di atas panggung sebelumnya? Memberikan kesimpulan atau mungkin pesan tentang bagaimana anaknya sudah berkembang sejauh ini. Terima kasih.
Tes. Ya, selamat pagi semuanya. Nama saya Ferry. Hari ini saya ada di sini bersama istri Yuwita. Saya orang tua dari Liam di grade 4, ya, grade 4. Pertama kali untuk yang scientist di sebelah kanan saya dan sebelah kiri saya, wow, 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 ya. Wow. Jadi saya ingin kasih sharing beberapa poin, beberapa kesan dari aktivitas anak-anak. Karena ada kesempatan 2 kali di rumah mereka kumpul, ya, melakukan aktivitas menyelesaikan tugas ini. Yang saya bisa yakinkan ke teman-teman sekalian dan juga young scholars bahwa saya hanya bantu menyediakan material dan tools, ya. Jadi tangan saya nggak megang sama sekali itu, ya. Di semua yang mereka tunjukkan itu tangan saya nggak pegang sama sekali. Saya duduk saja di meja mengobservasi aktivitas mereka. Yang pertama dari karakter dan attitude luar biasa. Saya harus kasih apresiasi ke sekolah dan guru, ya. Bagaimana mereka berinteraksi, ya, kita bisa lihat, ya, karakter mereka. Yang kedua bahasa, luar biasa loh, ya, bahasa Inggris mereka di depan luar biasa. Kemudian ide-ide mereka dan kemampuan mereka untuk mengolah material ini. Bayangkan kita dulu kelas 4 belajar apa, ya. Lihat sekarang kelas 4, kelas 5, kelas 6 SD. Saya rasa mereka pantas dapat A+ sekali lagi. Ya, poin terakhir untuk young scholars, ya, dan teman-teman Liam semua di QCA, dream big, ya, dream big. Uncle backgroundnya engineer, jadi setiap hari juga dealing dengan mechanical dan electrical engineer. So I would like to encourage you to look at the future, be a scientist, and see what the world and the universe is holding for you. Yeah, dream big. Okay, thank you, good luck.
Do you hear that, students? You need to be motivated to explore the world around you and be yourself, all right? Don't forget, you have God who will support you, who will provide you with everything that you need, all right? Amen. So, science explorers, we have a yell. Do you still remember our yell?
Yes.
Okay. So, let's stretch our body up, everyone. Let's stretch our body up. So, stand up. Grade 1, 2, 3, 4, 5, 6. No parents, but if you want to join us, yes, you are welcome. Okay, so science explorers
Exploring science from Earth to the skies.
All right. Thank you. You may have a seat. And the time has come for us to delve into the mysteries of lava with this fascinating lava lamp experiment. Please welcome our next group with the presentation of lava lamp experiment, group number 4. Please welcome, give a big hands for them.
Welcome, parents, teachers, and friends. Welcome to Science Project. I am Heavenly.
I am Bess.
I am Raphael. And Mark. Today, I am going to show you one of our experiment called lava lamp. And so now, I want to ask you, have you ever made a lava lamp at home? Well, if you hadn't, allow us to guide and introduce you to lava lamp.
Welcome, young scientists. Let's talk about our experiment called lava lamp. A lava lamp is a decorative lamp invented in 1963 by a British entrepreneur, Edward Carvin Walker, the founder of the lighting company Magnus.
How to make lava lamp, and first of all, materials. First, you need a jar or plastic bottles, then you need a baking soda, then you need a vegetable oil, and vinegar, and small container, and food coloring. First, we take a plastic bottle or a jar. Second, we pour the baking soda. Third, after the baking soda, we pour the vegetable oil. Fourth, another container, we mix vinegar with food coloring. Fifth, then we mix the mixed vinegar with food coloring with the one that has baking soda and vegetable oil.
Lava lamp has a bunch of uses, such as being a lamp, or just a decoration, or even being a toy. Some fun facts. Did you know that lava lamp was originally called an astroglobe? Did you know that the most expensive lava lamp was sold at 15,000 US dollars? Or in Indonesia, it equals to 234 million.
And now, what time is it? It's question time. Name least one most common uses of lava lamp.
What is it?
And now, we are going to make the lava lamp experiment. And first, we need ingredients. For lava lamp, we really need the vegetable oil. And we are going to need a baking soda, a food color, it could be any color you want. We need a vinegar, and a small container to mix it, and a LED lamp. So now let's get on to the steps. First, we pour a baking soda. Second, we pour the vegetable oil after the baking soda. And now, onto the other small container, we mix vinegar, with the food coloring. We mix it first and watch the show begin. turn on the LED lamp. And we could have a lamp. And it could be as a decorations and a night lamp, so it could guide you wherever you go.
Reaction between base 8 and oil at work. Can anyone explain the science behind it? Yes. There's a reaction that makes the lava seems like dancing.
Ooh, the lava seems like dancing. Who likes dancing? Do you like dancing?
Yeah.
As well as the lava. So, chemical reaction is interesting indeed. The electromagnetism is also wondrous. So, let's dive into this electric train experiment conducted by the 5th group from the 6th grade. Valerie, Eva, and then Dave, Aldrich, and also Lionel. Please welcome to the stage with their electromagnetism electric experiment.
Hello, everyone. Let's jump into our marvelous adventure of electricity and magnetism. We'll teach you all about our simple electric train by Lionel, Aldrich, Dave, Eva, and Valerie.
Firstly, we need to know, what is a simple electric train? A simple electric train is when you put a battery and a magnet through the copper wire and it makes just enough energy to make electricity. That reaction causes the magnet and the battery to move.
The materials to make a simple electric train are: number one, battery. A battery is a device that stores chemical energy and converts it to electrical energy. Number two, copper wire. Copper wire is a wire that transmits electricity from one point to another. Number three, circle magnet. A piece of metal which has a strong attraction to other metal objects.
Do you know how to make a simple electric train? The first step is roll the copper wire into a tube shape. The second step is take a battery, then put 3 magnets on each side of the battery. The third step is put the battery inside the copper wire and then give it a little push. Make sure the magnet touches the copper wire.
Now we will demonstrate how we make it. So we need
If
to
you
put
cannot see it clearly, you can see from the video.
So we need to put 3 magnets on each side of the battery. We need to make sure the magnets repel each other before putting it on. Now we need to put the battery inside of the coil of wire and it should run on its own.
My name is Aaron. And I'm Giselle. And Ilona. And I'm
Do you know why it happened? It happened because when we put the battery inside the coil of wire and both of the magnets are touching the wire, it creates a closed circuit between the two magnets and the current flows. As the current flows through the copper wire, a magnetic field is created around the wire. The magnetic field interacts with the magnetic field created by the magnets in a way that repels the magnet on one end and attracts the magnet on the other, pushing the battery through the copper wire.
Do you want to know another reason why the simple electric train can move? The other reason is a non-uniform magnetic field. A non-uniform magnetic field is when one end of the magnet has a stronger force than the other, which creates a difference between the two ends of the magnet.
Conclusion. When you move a magnet around a coil of wire, it pushes the electrons in the wire that makes an electrical current. And combined with the magnet, it is able to make the battery move.
Alright, question time. If you're paying attention to our presentation, you will be able to answer our question. The question is, mention all of the materials that you need to make the simple electric train. Mention all, please.
There are 3 of them, okay?
Feby. Oh, Vander. Abigail. Oh, right beside Feby.
Copper wire, magnet, and circle magnets, and a battery.
Congratulations, you're correct.
Yay!
Thank you for your attention and joining our adventure. We hope you enjoyed and God bless you. If you're interested in learning more about electricity or magnetism, you are very welcome to visit our booth. Thank you.
Thank you.
The train acting as a magnet. This is magic.
Yeah, it seems like magic. Electromagnetism, field, something that we cannot see, something invincible but exists. Something invisible but exists. And so is our God. Do you believe in electromagnetism, everybody?
Yes.
So you should also believe in our God, who's not also cannot be seen, but we can believe, we can sense him. And that was amazing. The presentation was amazing, although it cannot be seen, but we can see the process of it along the way. And now, do you want to see the mesmerizing world of light physics?
Yes.
Ooh. Now, get ready to be dazzled up by the Rainbow Desk Becomes What experiment. Please welcome the next group. Group 7.
Hello, Marfel.
Hi, Rania.
Do you want to know more about rainbow?
Yes, of course.
But how about the parents, teachers, and friends? Do you want to know more about rainbow? Okay, let's do our experiment.
But what is the experiment?
The experiment is rainbow colors make white.
The materials we need are cardboard, pencil, ruler, paint, paintbrush, a round object, and scissors.
How to make this experiment? First, cut the cardboard into a circle. Then make 2 holes in the middle of the circle. Then divide it into 7 parts. After you divide it into 7 parts, you paint it into the colors of the rainbow, which is red, orange, yellow, green, blue, indigo, and purple.
How do we play it? So first, you spin it by holding the 2 strings. Then you pull it. If it doesn't become...
Oops! Something wrong. Can we do it again? Okay, let's do it again. Wait for a moment, okay? Let's do it.
If it doesn't become white, there must be something wrong, and you need to do some tries.
Why does it become white? This happens because sunlight is a combination of the rainbow colors. This combination is called white light. In order to make rainbow, we need water droplets, sunlight, and an observer like us. This is why rainbow appears after raining, because raining is when water droplets fall from the sky, and after raining, the sunlight appears.
Parents and teachers, today we're going to do our science fair. Rainbow color makes white.
The material we need is cardboard, scissors, ruler, pencil, acrylic paint, white string, and paintbrush. This is how to make. First, you cut the cardboard into a circle with a scissor. And after you've done that, make 2 holes in the middle of the circle. The distance shouldn't be too close. After that, you divide it into 7 parts. After that, you paint it into 7 colors of the rainbow, which is red, orange, yellow, green, blue, indigo, and purple. You do it. If you want to play it, you need to spin it. After you tingle, you twirl it. Sometimes it doesn't work. It needs some strength. Thank you, teachers and parents and friends, for listening to our presentation. God bless you. Who wants questions? The question is, what phenomenon of splitting white light into 7 colors is called? A. Reflection, B. Refraction, or C. Dispersion?
Yes. Warren?
Reflection. I'm sorry, but that's wrong.
Try again next time, Warren. Thomas?
Refraction. I'm sorry, but that's wrong too.
Uh-oh. Okay, last one. Stanley, Stanley.
Dispersion.
That's right. Thank you for your attention and patience. And don't forget, go to our booth and buy our eco-friendly products. God bless you.
God bless you.
Well, the presentation was mesmerizing, wasn't it?
Yes, it was. It is.
It's showcasing the fascinating world of color missing and the magic light.
It was a captivating trick played by light.
Yes, it was. Baik, setelah melihat beberapa penampilan yang menakjubkan dari grup-grup yang telah tampil sebelumnya, mari kita beri tepuk tangan sekali lagi yang paling meriah untuk anak-anak kita dari grup dari lower grades dan higher grades. Baik, adakah dari Bapak Ibu yang ingin memberikan respon atau kesan atas penampilan ketiga kelompok sebelumnya? Oh baik, Ibu Aneke. Baik. Kita berikan tepuk tangan sekali lagi untuk Ibu Aneke untuk memberikan kesannya. Terima kasih, kepada waktu dipersilahkan.
So excited ya. Keren banget. Kalian semua hebat. Ini saya bisa bilang bahwa acara ini sangat bermutu. Karena memang dalam satu acara ini banyak sekali hal yang bisa dipelajari. Dari teamwork, terus ya kerjasama kelompok ya, berbagi tugas. Kamu ngerjain apa, yang satu mungkin sudah selesai, satu belum, kok kamu belum, dan sebagainya. Dan ada juga masalah tentang menyiapkan barang-barang yang akan dijual, itu hal yang sebenarnya cukup rumit untuk anak usia 4-6. Betul seperti kata papanya Liam tadi ya, bahwa di zaman kita kelas 4, 5, 6, tahu apa sih kita. Rasanya begitu ya, nggak pernah ada proyek-proyek ya serius. Jadi saya cukup happy dan happy banget karena QCE mempunyai acara yang sangat bermutu seperti ini, event yang serius digarap dan di mana anak-anak bisa belajar banyak dan bahkan orang tua pun bisa ikut melihat, mengawasi dan ya memberikan masukan-masukannya, dan itu sangat bagus, kolaborasi antara orang tua dengan anak. Dan saya harap event ini akan bisa terus diadakan dan hasilnya akan kita lihat nanti. Puji Tuhan, terima kasih.
Alright, science explorers.
Exploring science
From
Earth to the sky.
Okay.
Get ready to embark on an exhilarating adventure of marbles, ramps, and the law of physics.
Ooh, exploring the adventure of marbles, ramps, and the law of physics. Who will deliver this experiment? What group is it now?
7.
Group 7. Please welcome the 7th group to the stage.
Hello everyone. Are you ready for an exciting and new adventure about marbles? But first, let's introduce ourselves. Hi, my name is Vern.
Hi, my name is Marvel.
Hi, my name is Clara. And hi, my name is Patras.
And my name is Stefania.
Have you ever played with a marble run? Do you know how it works? It works by using force and motion. But what is force and motion?
Motion is a change of a position of an object, and force is something that helps them do this.
Explore the world of force and motion with this simple marble run. Just through this experiment, we will understand how objects move and interact with one another.
The materials to make the marble run is a box, cardboard, transparent paper, scissors, cutter, glue gun, a plastic bottle, toilet paper rolls, and a marble.
How do you make it? Well, these are the procedures. First, cut a hole in the box. Second, cut a tube according to the size. When you're done, cut another hole in the box and make strips with cardboard 2 times. When you're done, cut the tube into pieces and paste it.
Step 7. Cut the end of the run. Step 8. Cut bottle for the marble to stop. Step 9. Paste it. Step 10. Cut transparent paper. Step 11. Paste it at the front of the marble run. Step 11. Paste it at Step 12 with another tube. Paste the rubber. Step 13. Paste the tube at the start.
And this is the final result. And if you can't see the demonstration, you may look at the video on the slide. So what you need to do is you take the marble and you stretch it on the rubber like a slingshot. And you let it go and it will run through the marble run.
Result: the marble will not fall out of the marble run and it will be stable. When we stretch the rubber at the top of the marble run, we are giving potential energy. When we let go of the rubber band at the top, the marble starts going fast because the potential energy is transformed into kinetic energy.
Do you know why the marble rolls down? Because of gravitational force. It pulls the marble downwards. From this marble run experiment, can you see that the marble runs slower? It is because of friction between the surface of the ramp and the marble.
The marble will not fall off the marble run and it will be stable. From this marble run experiment, can you see that the marble runs slower?
Parents and teachers, today we're going to do our science fair. Rainbow color makes white.
The material we need is cardboard, scissors, ruler, pencil, acrylic paint, white string, and paintbrush. This is how to make. First, you cut the cardboard into a circle with a scissor. And after you've done that, make 2 holes in the middle of the circle. The distance shouldn't be too close. After that, you divide it into 7 parts. After that, you paint it into 7 colors of the rainbow, which is red, orange, yellow, green, blue, indigo, and purple. You do it. If you want to play it, you need to spin it. After you tingle, you twirl it. Sometimes it doesn't work. It needs some strength. Thank you, teachers and parents and friends, for listening to our presentation. God bless you.
It is because of the friction between the surface of the ramp and the marble.
From this marble run experiment, we can make the marble run faster or slower by stretching the rubber harder or less hard.
So what's the conclusion? The conclusion is through this marble run experiment, we can learn how potential energy can be transformed into kinetic energy, making the marble runs down the ramp, and how friction can affect the speed of the marble.
It's time for questions. If you really paid attention to our presentation, you will know the answer to this question. The question is, how does the marble run works?
And these are the options. A, force and motion. B, force and magnets. C, motion and magnets.
Would you
The
repeat
question?
the question one more time, slower?
The question is, what makes the marble able to run? A, force and motion. B, force and magnets. C, motion and magnets.
Yes, Rick.
Force and motion.
Yes, that's correct.
Oh, congratulations.
Thank you for listening and paying attention to our science fair project. We really hope you like this new adventure about marbles. I really hope you do like marbles. And also, if you want to learn more, you can visit our booth and you can buy the eco products. God bless you.
Hello everyone! Get ready for an exciting journey into space. I'm Annabelle.
I'm Emily.
And I'm Daryl.
In this presentation, we will learn about solar and lunar eclipse. We will use a cool model to show you how they happen. In this model, you can see that there is 3D Earth, Moon, and Sun. What are the materials needed?
The materials are styrofoam ball, iron wire, LED light, cardboard, paint, light bulb cover, and AC slow running motor.
Do you know how to make solar and lunar eclipse working model? Well, it's quite simple. First, cut cardboard to make the stand for the 3D Earth, Moon, and Sun. Second, paint styrofoam balls as Earth and Moon.
Third, stick the light bulb cover to the stand of the sun. Fourth, stick the AC slow running motor to the earth to enable the earth spinning.
Fifth, stick the iron wire to the moon. Sixth, connect the other end of the iron wire to the earth. 7. Stick the LED light to the stand of the earth for stars and decorations.
Now, let's see how they work. What does this mean?
This is solar eclipse. Solar eclipse happens when the moon passes between the sun and earth, blocking the sun's light for a short time. This creates the moon shadow on earth. Therefore, when the solar eclipse happens, the sky will look darkened.
Other than that, there is also lunar eclipse. Lunar eclipse happens when Earth positions itself between the sun and moon, blocking the sun's light from reaching the moon. When lunar eclipse happens, the moon will look reddish-brown. Why? Because the Earth's atmosphere absorbs the sunlight and bends some sunlight towards the moon. In simple words,
The difference between solar and lunar eclipse is their position.
understanding solar and lunar eclipse helps us learn how sun, earth, and moon moves in space. They are like nature's magical show in the sky. Oh, we're not done yet.
Here's some fun fact about solar and lunar eclipse. In ancient China, the solar and lunar eclipse were regarded as heavenly signs that foretell the future of the emperors. Fun fact 2, you could see lunar eclipse from the moon. Fun fact 3, in Italy, it is believed that flowers planted during solar eclipse are brighter and more colorful than flowers planted in other time of the year.
Question time. What are the materials that we need to make the earth and the sun, the moon?
Yeah, Nadia.
Sun. Sun.
The question is, what materials do we need to make the moon and the earth? How to make them?
Materials.
1, 2, 3.
Materials.
Yeah. What was it?
Materials.
Material. Yes, that's correct, kinda. Well, who's next? Yola. Okay, Yola. No. Oh. Kalea.
Is it foam balls?
Yes, that is correct. Good job.
Thank you everyone for paying attention to our science fair presentation.
If you are interested, you can make this by yourself at home. And don't forget to visit our booth. Bye!
It's been an enlightening journey. Each experiment has left us in awe of the natural world and the laws that govern it.
The entire scientific presentation filled with captivating experiments and mind-boggling discoveries. Can you feel the excitement in the air, fellas?
Yeah.
Can you feel the excitement in the air?
Yes. Indeed, science never fails to amaze us, and we've saved the best for the last. Be prepared to be amazed as we combine the principle of freezing and heat transfer to create a mouth-watering ice cream experience.
Ooh, ice cream.
Ooh, ice cream.
Please welcome the
Yum.
next group.
Group 9.
Group 9 with mouth-watering ice cream experiment.
Good morning, parents, teachers, and friends. Today, we are going to present about making ice cream in a bag. But first, have you ever made ice cream without putting it in the freezer? Well, if not, we are going to show you in this science presentation today.
We will explore the science behind making creamy ice cream using just a few simple ingredients and a bit of shaking magic.
The ingredients are salt, ice cube, ice cream powder, cold water, and then 2 Ziploc.
The procedures are: first, get all the ingredients. Second, mix ice cream powder with water. Third, pour the mixture of ice cream powder and water into a medium Ziploc. Fourth, pour the ice cubes and some salt into bigger Ziploc. Fifth, put the Ziploc contents of ice cream liquid into the bigger Ziploc. Put the Ziploc contents of ice cream liquid into the bigger Ziploc. Shake it for 5 minutes and wait until it turns solid. Serve it in a small cup and add your favorite toppings. Enjoy your ice cream. This is the video. Good morning, friends, teachers, and parents. Today we are going to show the example of ice cream in a bag. So the ingredients are: you need water and
ziplock and ice, and then pour the salt into the ziplock. After that, you close it and then shake it in the lid.
After that, you take the medium ziplock, you open it, you pour the ice cream powder inside the ziplock. After you pour the ice cream powder, you pour it with water. You close it. And then you mix it evenly. After this, you put the liquid ice cream into the ice bath salt. After that, you close it tightly. After that, you shake it for 5 minutes. After 5 minutes, the ice cream will become solid. See?
Wow, amazing guys! So if you want the ice cream, come to our booth. Just try this ice cream. Thank you friends, and thank you teachers and parents and friends for listening to our presentation
For today.
If you want to try the What happened during the ice cream making? When we add salt to the ice, the freezing point of the ice will be lower. It creates a cold environment for the freezing the ice cream mixture. When we shake the ziplock containing ice cream mixture, the ice cold temperature from the salt ice cube will transfer to the mixture inside the ziplock.
The conclusion is, from the experiment we will learn that by using salt and ice, we can make an ice cream by shaking it in a ziplock. It shows that different materials can change from one state like liquid ice cream to another state, like solid or creamy ice cream. The salt lowers the freezing point of the ice cube, so the coldness can transfer to the liquid ice cream to turn into solid ice cream.
Question time. What ingredient do we need to make the ice cream?
Denzel.
Ice cream powder, water, salt, and ice.
Ice cream powder, salt, water, and
Yay,
ice.
you're
Yes,
correct.
you're right, Denzel. You're real the president.
Thank you for all your attention to watch our presentation.